going to talk about debugging like Feynman and Bayes, Richard Feynman and Thomas Bayes. And hat tip to Josh, who I just met for my brand new subtitle as of a few minutes ago, Advanced Conversations with the Rubber Ducky. So have you ever felt like this when trying to debug a particularly tricky problem? If so, this talk is for you. So I'll start with a little story about a problem that I was once debugging in my work at Udemy. So at Udemy, we have a website, we sell online courses, and we have text translated to a bunch of other languages on our site. We have a translation pipeline that's got all these complicated pieces. We have to gather strings from the code base, format the strings, write those to a file, ship that file out to a third-party service where the translation gets done by some magic process of humans and machines working together. And then we download the results, and then we format the results, put the translation file in the right place, and then we can see translated text on the website. So I was doing a fairly mundane update of some of the legal documents on our website, where we go through an extra rigorous process of translation and QA, and we make sure all the pieces are in place because we want to make sure the legal translations are exactly right. And I had everything queued up exactly like it needed to be. I verified at the end of the day, okay, I have all the translations ready to go. I can release this change tomorrow, first thing in the morning, and I've got all the pieces. So then I come in the next day and I go to release this thing, and the translations are missing. So I started looking around and checking all of these pieces of the process. Why the heck are the translations missing? And so I was doing a version of the process that I'm going to describe to you momentarily, checking each piece along the way. Turns out, eventually I discovered that a dear colleague of mine had gone in and cleaned up excess translation files in the time between when I had checked that everything was there and when I went to release, through no malintent or anything, just trying to, oh, there's extra stuff in here, we'll just clean it up, and deleted some things. And then I kind of got screwed by that. So that was a fun application of the debugging process that I'm about to describe. Before I go into the actual process, though, we're going to talk a little bit about sort of some foundations and principles that give rise to this process. So when you're working on a particularly nasty bug, you spend a lot of time trying to figure out how or why it's happening, and then only a very small amount of time actually fixing the bug. So you may spend 2 or 3 weeks working on something in order to produce a 2-line pull request, because really the work is over here in trying to understand why that thing is happening, and it's the understanding part. It's the cognitive process that we're going to focus on here. So when we talk about understanding why a bug is happening, implicit in this is that there's an idea that the bug is something that's happening in external reality, which is different than what we predict or intend to happen based on our model of the world. So these are two separate objects. There's the model, which is this thing that's happening in the meat of my brain, and then there's external reality. And a good model approximates reality and gets feedback from reality to update to become more accurate and more useful. So we're going to talk a little bit about the process by which that cycle of approximating reality better, getting feedback, and updating works. So this is where our friend, the Reverend Thomas Bayes, comes into picture. So this is Bayes' theorem, which is a very important idea in probability and statistics. The key idea here is that the posterior probability of some event given some evidence can be calculated based on a likelihood of evidence given some model times the prior belief normalized by the evidence. And we're not going to go too deep into the math here, and I'm going to pretend that that's because I only have a 15-minute talk and not because I took these courses in statistics a long time ago and I don't remember all of these things, but pretend with me that it's only because I have only 15 minutes. But if you want to get into the math, when we share these slides out, there's a link in the bottom right that dives into that. But the key idea here that we're borrowing from Bayes is, this is paraphrasing or quoting from this book, Super Forecasting by Philip Tetlock and Dan Gardner. The key idea here is that it's not that you're crunching the numbers so explicitly, but what matters far more is Bayes' core insight of gradually getting closer to the truth by constantly updating in proportion to the weight of the evidence. So that's the principle we're going to use to motivate this process for debugging. So we're going to work on this feedback loop, making the model approximate reality better. Okay, so now let's get into the meat of the process. So the first step of this process is to write down a clear description of what you're observing and how that's different from what you expect to observe. This step doesn't actually have anything to do with this Bayes or Feynman stuff. It just helps focus the rest of it. So do that thing first. And then the next step is to collect all of your current hypotheses for why the bug is occurring. So each hypothesis is sort of an output of a model that's running in your brain for why the system is producing the output that it's producing. So you may be able to come up with a number of different models that could explain why something is happening that's different than what is intended. So why the bug is happening. So we're going to list out all of our hypotheses for why some particular bug is occurring. So here's an example. Our first hypothesis for why the bug is happening is because we did not moog the blurg. Second hypothesis is that there's a bug in version 40.7.3 of this mature and widely used open source library. Usually that hypothesis is less likely. Hypothesis C, gremlins, always a possibility. Hypothesis D, the blurg was unmooged by a later process. So once we have all of our hypotheses listed out, the next thing we're going to do is sort them by our likelihood. This is where we bring in the prior information part of Bayes' theorem. So we may have prior guesses about which parts of the system may be flaky. And so what we'll do is reorder our hypotheses in order to represent that we think hypothesis A is most likely and then hypothesis D. Next thing we're going to do is, starting at the top, we're going to start to conduct mini experiments that are going to help us get feedback from reality to update our models. So starting with hypothesis A, we did not moog the blurg. How can I test whether or not the moog was blurged? If the blurg was not mooged, what would we observe? So then let's go and run some experiments. And when I say experiments, I mean little things like I'm going to log a value that tells me something important about what's happening in the system. I'm going to go to my dev environment and change some variable. I'm going to inspect the page source in production, tweak the live CSS, run a query against the database, throw some error in some place that might be informative. Basically, I'm going to do some interaction with the system that's going to tell me some new piece of information that's going to either support or discredit the hypothesis in question. Once we do that little experiment, we get a little bit of information back. We get that feedback from reality. We're going to update our belief about the likelihood of that hypothesis being the one that explains why the bug is happening. So let's say we run an experiment that suggests that we did, in fact, move the blurg, and so this hypothesis, hypothesis A, is less likely. So we're going to reorder our hypotheses, moving A down, and so now hypothesis D is our top hypothesis. So now what we're going to do is repeat the process, starting with our top hypothesis. We're going to say, well, how can I test whether this thing is the thing that's causing the bug or not? Propose some experiment, run the experiment, get the results back from our experiment, and use that to update our likelihood, our belief about whether that hypothesis is the one that really explains why that bug is happening. Once we do that, then we reorder our hypotheses again. So as we do this process, you might start to see that there's an algorithm here. There's an algorithm that we can extract. So here's the algorithm that I'm proposing. While the bug is not fixed, set hypotheses equal to, if we have any prior hypotheses, plus propose new hypotheses. And then take the top hypothesis as the first of hypotheses sorted by likelihood. Propose some experiment to test the top hypothesis. Conduct the experiment, get the results. Use those results to update the likelihood of the top hypothesis. Repeat until you have discovered the cause of the bug. So that's the basic framework of the algorithm. But sometimes these parts are kind of hard. Proposing new hypotheses, maybe you kind of run out of ideas here. Proposing experiments, same thing. Maybe kind of run out of ideas about how you can test whether or not something is the cause. So if you get into that point and you're kind of stuck again, and you're thinking, oh, it must really be gremlins, this is where the Feynman technique comes into play. Very briefly, Richard Feynman, brilliant astrophysicist. He's known as the great explainer. Very interesting guy to listen to and read. I'd recommend go read his Caltech commencement address and watch this fun video. But the Feynman technique is as follows here. So you grab a notebook and write down everything you know about how the thing works. And Richard Feynman was doing this about astrophysics. And then as you're writing down everything you know, you need to pay very close attention to the quality of your explanation. So when you notice that your explanation is a little fuzzy, or you can't really explain clearly why something is happening, that's the thing to focus in on, because that represents a gap or a weak spot in your mental model. So then you use that gap or weak spot as a jumping off point to learn more about the system, or to propose experiments that would help fill in that gap in your mental model. And so Richard Feynman would be doing this. He would be writing down and notice that, oh, there's a weak spot in my understanding of this area. I need to go learn more about this. Go do that, learn more about it, repeat the process of writing down everything you know about it until you're satisfied. So here's an example of someone implementing the Feynman technique in order to study Bayes' theorem. So the metaverse folds back in on itself here inside of my talk. So this person is writing down everything they know about Bayes' theorem. They're saying it's a rule and formula in probability theory, and here's the formula, and here's what all the variables mean. And then if I were doing this, if I were writing this down, I would actually say down here at the bottom when they say probability B given A is the inverse, it's the probability, blah, blah, blah. I'm actually, from my stats background, I forget if inverse is actually the right terminology for this. So I would say, oh, that's a weak spot in my understanding. I'm going to go and just learn more there. So using the Feynman technique, we're going to update our algorithm to include a few additional steps. So while the bug is not fixed, take existing hypotheses and add new hypotheses. And if you don't have any hypotheses, invoke the Feynman technique. And then again, take the top hypothesis sorted by likelihood, propose an experiment to test that top hypothesis. If you can't come up with any experiment, if experiment is none, invoke the Feynman technique again, and then conduct the experiment, use the results to update the likelihood, repeat until you have solved the bug. And I will make the bold claim that I have used this process effectively to solve, basically every bug that I've been motivated to really fully solve, continue with this process, and it has led to resolution. So, in summary, this is the proposed approach here that I'm suggesting. So first, describe the bug or unexpected behavior clearly. Next, write down your list of hypotheses for why it's occurring. Next, rank the hypotheses according to your current estimates of likelihood. And then propose and conduct experiments starting at the top of the list. Update likelihood estimates and re-rank. If you run out of ideas, try the Feynman technique. Eventually, you should be able to find and solve the issue. And finally, profit. So that is all for my talk. Thank you so much for your attention.